So friends, I'm back. You can still find me on Twitter at TerraJobs. Hopefully my voice is now better because I just restarted the stream. Okay, considering at least one person says yay, I honestly no idea what's going on. So I've not changed anything. All I did is restart OBS, which was already running earlier just fine. Maybe it's really time to just buy a better PC, because I think some of it might just be CPU issues on this laptop. Alright, so of course I closed my browser window for some reason. Alright, so let me just recap what I said earlier. So basically, last week what we did is not last week, 2 days ago, we did basically the grunt work to get syntax information into our bound representation. So our bound representation now has back pointers to the syntax nodes, which gives us the ability to say in the back end, okay, which syntax node, and then by extension which file name and span in the file name a particular intermediate representation originated from. And that gives us the ability to use that to emit debugging symbols, which is what we want to do today. And debugging symbols are then used by the debugger, so that when you actually set breakpoints, or when stuff happens, the debugger knows which region of source code this actually relates to, right? Because if you think about it, fundamentally, the best the runtime can do is relate machine instructions back to IL instructions, right? But IL instructions don't necessarily have any information with them, which source code they came from, which now makes it not very useful, right? And so it's for the debugger to show you effectively the big yellow bar that tells you what current statement you're about to execute. It would somehow have to know that the following 6 IL instructions correspond to this method call. And that's the thing we want to do today. All right, so let me just jump in and see where we are. So we'll start with emerging PRs really quick because we don't have that many today. Let me start with the simple one here. So Lucas added, shouldn't say add, but extended our hack that we currently have for generators. So as you probably remember, we generate C# files. I should say we generate C# as part of the build using the new C# 9, I guess, source generators feature. And our IDEs don't really know about it yet, except for Visual Studio. So Writer doesn't know about it, and neither does VS Code. And so we have this hack where we actually write a file to disk, and then we exclude that in MS Build because VS Code doesn't use MS Build, but Writer does. But apparently Writer doesn't support source generators either. And so what this hack does, it basically just says, well, we do this hack only when we're not running inside of Writer, right? So that seems reasonable. I can't test it because I don't have Writer, but that seems like a reasonable short-term thing. There's already a big marker on top of it that says hack, 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 please remove me. So it's just adding another work item to that. All right, and then there's here a cool feature done by, probably butcher your name now, Alberto, who added the support for minus equals, star equals, slash equals, plus equals, right? All the compound binary expressions with assignment combined. And last time I gave him a bunch of feedback. So particularly the thing I didn't like was that we introduced a new syntax node for that, because we could have just reused the assignment syntax, and so he changed that. I already gave it a review last week, and I gave it a quick review, I think yesterday. So it looks great, so I will take that as well. And then, yes, I've been a bad boy. I haven't merged last episode yet. So today we will just create a new branch and base it off of the episode 27 branch, because we will need that data that we generated last time. All right, so let's first talk about how we actually do the debugging symbols. So basically, let's go to the emitter here, which unfortunately is also something that we need to clean up. There is quite a bit of a mess in the constructor going on here. But basically the key message here is, the key function here is emit, that drives the whole thing. So what we basically do is we create an assembly definition with our library called Cecil, and then we write it out. And for debugging symbols, we don't have to do much. there is this other overload here that takes writer parameters. And so what we will do is we'll just construct them. So writer parameters, new writer parameters. And when I remember correctly, let me actually cheat a little bit and look at my nodes, which fortunately are on my different screen now, because I like to make my life simple. Okay, show this window on all desktops. Here we go. And yeah, basically what we have to do is we just have to say write symbols. So write symbols will be true. And then of course we have to say where the symbols go. And right now what ends up happening is we get a path. I just apparently navigated by accident. So one of the things that we have to say is where the symbols go. Right now we only have an output path, and that's where we write to. So we can just cheat right now. In order to get this thing going, we would say debugging, I guess symbols path is path dot now I guess change extension in our case, change the extension for output path. And then we have to include the period in this, and not DLL, PDB of course. And then we basically have to create two streams, one for our output. So we say output stream is new file, I guess not new file, write. I guess no, file create for output path. And then we do the same thing for symbol stream. I guess you probably should have these writer symbols outside of this. Or actually we probably have to have them inside of it anyways, because we want to write here. And then I think we just have to specify the stream here somehow, right? Yeah, symbol stream, we have to set this to our symbol streams. And then the other thing I think we need to set is the provider. So there are different formats you can use for symbols. I think it's portable PDB writer provider, maybe. I think that's the one. And so basically there's the normal format that Windows has been using for years, which is the normal native PDB format that came from C++. And the downside is that that is a Windows only thing. And so there's this new thing called portable PDBs, which is mostly a .NET thing. And so the way they look pretty much identical to regular PE files if you actually open them up. They just have additional tables actually in them that have debugging information. And so they're easier to read. And that's what we are going to use. And then I think all I have to do here is, what do I call here? I call, I think yeah, it looks like I basically just have to say output stream and then writer parameters. And so what this will do is it will now emit PDB files, but of course we haven't done anything that would create anything yet, but we should at least be able to go to our samples here and see what's going on there. So let's go to hello and let's just .NET build this guy. I guess I did not specify the path here. Yeah, use the same path here. That's of course not very smart. So let's try this again. Any chance you can do a stream on source generators? Can you explain what you mean by that? So I did a stream on source generators in that I use C# source generators in our compiler to make our lives a little bit easier, which basically will tell you how to use a generator. Or do you mean do a stream on extending our compiler to have the concept of a generator, which is kind of a level more meta? All right, so now we have this guy here. So let me just open the path here, and we should see a PDB file next to it. And here we go. That's the PDB file we just emitted. So of course now nothing will happen if you start to debug this. We still don't have any sequence points, so this is not going to be super useful. So now let's do the next level. How we want to do sequence points? Well, logically the way a sequence points works in IL is that there's just corresponding information in the CCI object, so in the CESL object model, that basically says these IL instructions correspond to this sequence point. And so for us, in order to manage sequence point, we will just do what we do for everything else that we track. We will have a new kind of statement, and this new kind of statement is the sequence point statement. Bound sequence point statement, which will be a regular statement. And so what this will also allow us to do is we will be able to use our normal infrastructure to effectively decide. Jesus, this guy is not very smart, is it? To decide also where sequence points lie, because as I said earlier, there is a little bit of a irregularity there where we want to make debugging experiences nice, and that means we need to control very carefully where sequence points go. So to give you some ideas, right? So for example, when you enter a method, what C# does, it says a sequence point on the opening brace and on the closing brace. And the opening brace is basically as soon as the method is being entered, you get a breakpoint there. And then the closing brace is every basically exit position in your statement. So in your method, you may have return statements here all over the place, but you can just set a breakpoint on the closing brace. So that means no matter where you exit your method, you always get a breakpoint there. And so in order for us to do that, we have to make that happen, right? And put the sequence points in the right spot. So in our case, we will take a syntax node. We take a bound statement, which is the statement that the sequence point basically wraps. And then there is a location. Do we have a location type? I think we do, right? Don't have a location type? We do have a location type, don't we? Oh, I'm imagining this. Or we call it text location. Fine, be like that. And then text location is what I think it is, right? Yeah, it has basically the source text and the span. Okay, cool. Location. So you might be inclined to say, well, why isn't the location just the syntax location? Well, as I said earlier, we may want to put it on the opening brace, right? And there's no syntax node for the opening brace, right? The opening brace is the entire block. I should say the syntax node is the entire block, but the location might only be the location of the opening brace, right? All right, so let's just have that for now, and then we say base is syntax, and then everything else is just business as usual. Create a property for that, create a property for that, and then we have to return the bound node kind here, which would be bound node kind sequence point statement, right? So in order for this to not blow up immediately, we have to handle this in our bound node rewriter, which is here. So we have a new kind of statement. Sequence point statement. I guess technically speaking, I want this to be before that, but it doesn't really matter, I guess, in our case. Not sure exactly why my syntax editing is now all messed up, but hey, can't have it all. So we basically say we write statement on the node statement. Call the statement. And then we say if this is the same as this one, then we return it. Otherwise, we return a new one. Statement for node location. What's your problem with that? I'm very confused by the error messages I'm getting here. Apparently I can't type. Alright, so yeah. So cool, now we have that, but we haven't done anything with that yet. So in principle, now we only have to change the emitter to actually emit this guy. So let's start with emitting sequence points. The way this will work is we have here similar an expression statement, and we would add a new one, and we say this is the sequence point statement. And so we would just say emit sequence point statement for bound sequence point, and then we just have to implement this guy. So how would that work? Well, let me just quickly take a peek again so I don't forget what it is. Yeah, so effectively there's a few things we need to do. So in our IL processor, we can ask for the body instructions count. So var instruction index, or I guess index, is how many instructions do we currently have. Then we say emit statement for a node statement. And now we can get the actual instruction, which is, of course, at that index location, right? I guess we have to pass in the IL processor here. So now we know the instruction that this guy came from. And then basically what we have to do now is we just have to say, give me a sequence point for that. And so logically a sequence point is, as I said, a particular location in the file and the file itself. So basically what we need to do is we just have to say, what is it? IL processor body method. So the method itself has debugging information, and we can say sequence points dot add, and we need a sequence point. So let's create a sequence point. Well, sequence point would be new sequence point, and then this guy gets an instruction which we currently have, and we need a document. So where do we get the document from? Let's solve this as well, but first let's add this guy here. So what is, and I guess there's a few other things we need to set, to do set text information. But first, let's get the document. So the way this works with documents, so there's basically this very simple thing. We just have to say new document, and we just give it the URL or the path effectively where this document lives, which in our case would be simple because we can say node location text file name, right? That's the file name. But of course, we don't want to emit a new document for every single thing. So we would have to keep track of our documents, which is not that hard. All we have to do is just build ourselves a little dictionary that does that. Private dictionary. Would that be text? I guess source text. No actions available. What do I call it? Did I not call it source text? I thought I did call it source text. Yeah, I did call it source text. Source text. Document, and we call this documents. And they are all non-nullable, that is right. And then all I have to do here is I can say if, I guess, if documents try get value for no text out bar document, we can't find this guy, then we create one. And then we say documents, add typing today is harder than it used to. All right, so now we have a document. And then for the sequence point, we basically have to say, well, where is this guy? And so this way sequence points work. There's start column. There's start line, and then there is end column, end line. And the important thing here is they are 1 based, not 0 based. So that means in our case, we would say node location, start line plus 1, because we are 0 based, start character plus 1. And now I kind of regret that I copied and pasted it too early. So now we just do this, call it end, and of course misspell it in the process, because why not? And now we have that, and I think I could even do a collection initializer, which apparently there's no refactoring for that, which is quite sad. Here we go. This looks roughly right. Great. Start line. Start character. Yeah. Swapping these things is always good. Consistency for the win. All right. And of course, it's called column here. All right, so far so good. Now the only other thing we need to do is actually create these sequence point statements, because we currently don't have them anywhere. And so I think the easiest way to do this is in the lowerer, because that's where we already do the rewriting. So let's just start by saying one of those things where I wish the VS Code support would be slightly better. So this is rewrite expression statement, bound expression statement. So what I will do is I will start with saying every expression statement will be wrapped in a sequence point statement. And we say this is a var result. I guess let's do this. Let's say statement. I guess you can say node equals base rewrite expression statement for node. What's your problem here? I guess in our case you would have to cast this guy. Nah. Rewritten node. That's probably the cleanest way to do it. And then we just say this is a new bound sequence point statement for node.syntax for the rewritten node. Probably we should use the rewritten node syntax then as well. And we say location, we would say rewritten node syntax dot location as a starting point. Okay, let's see how that goes. We explode. Okay, that's a good starting point. Interesting. So our basic block builder no complaints. I guess that's a good point, which I haven't considered. Control flow graph. So let me take a quick look again. Which line number is that? It's 115. Yeah, so what does that mean? We can probably treat them the same we treat expression statements, would be my guess. Probably have to add this to at least one more switch statement somewhere. Yeah, 103. I guess we can just search for switch statements here. Let's start at the very top. So that's the one we just added. Yeah, I think that's probably the same thing here. We can probably say this is a sequence point statement. Yeah, so there's only 2 hits for this. And then while we're here, the evaluator probably also has to do that. And this one might be actually quite hard because of the way this code is structured. Yeah. How would we do that? How would we do that now? We probably wouldn't do that. Probably what we would do is, So what is body? Oh, we directly go over that. Ta-dum, 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 ta-dum. Yeah, that's unfortunate. So this will definitely explode here if we don't handle that. Let's first tackle the other one. So there's another one that we need to fix, which is the bound node printer or something. So that should be a very easy case. Expression statement. So let's add this guy here. This is a sequence point statement. And then we would put this guy here. So how do we want to render these guys? Well, probably the easiest way would be do we have something like write comment? Don't have write comment yet. That's unfortunate. Sequence point. And then basically we could say the text would be node location text toString for the span, and the span would be node location span. And so we would just say the comment is this. So let's say write comment would be string text, and we say comment. Do we really have no comment stuff here? No, we do not. Alright, so then foreground color would be dark green probably. Reset the color, and then we say write text. Probably good enough. So we do handle knobs here. We probably handle knobs here would be my guess, right? Yep. Okay, so that seems, what about here? Do we handle knobs here? Yes, we do. So the only thing now we have to really do is somehow figure out how we can do this expression statement stuff. And so logically, sorry, the sequence point statement stuff. So logically we just have to kind of inline that guy. And the easiest way to do that is probably to cheat. So how about we do this? Statements. Statements is body statements not that it really matters. To array, let's say. Alright, and then instead of saying body statements here, we just say statements. And now we just do for each var s in statements. And I'm lazy here, convert this to for loop. We are basically saying if This guy is a bound sequence point statement. Then we just say this guy is as statement. In this way, we basically inline it logically, right? Let's try this one more time. Write comment should handle // by itself, right? Probably. I can get behind that. Yeah, I guess that probably works better for us. So find all references, which I can never remember the shortcut for apparently. Yeah, it's not always going to be a single line that is true. So what happens if this thing is on multiple lines? How would be a convenient way for us to do that? We can probably say start line is get line index for, okay, maybe at this point I should really say, well, span is this guy. And we can say this is source text, node, location, text. Makes it slightly easier. Alright, so that is get line index for span start. And then this is the thing for end. So this would be the end line. And then we would say var for each var I equals start line. Potentially -1 because end does not include. Yeah, end is not inclusive, so that's -1. Less than end line. I++. And then we would have to say this is the minimum. I guess the maximum. The maximum of, okay, let's get the line first. This is source text lines I. And that is the maximum of start, of the line start and the span start. And then the end is the minimum of line end and our span end. And then we say the line span is now text span from bounds start comma end, right? Because we have to clip this guy, right? And then we say text is this guy, and then that's what we output. Again, not that it is probably will not happen today, but hey, let's make sure it does. Okay, now let's run MSI, which of course I can't. And now let's say show, I guess, yeah, I guess, what is it, show program? Now when I say 1 + 3, we get this, which makes sense because this is a return statement, not an expression statement. So let's do the slightly more sophisticated version of that, and let's say print hello. Yes, and now we kind of fill the recursion portion here. Probably in our printer, right? Bound node printer. What is it? Sequence point. Right, sequence point statement. Yes, we also have to recurse into the statement here. Jesus. I'm not good today. Alright, so that should fix that problem. I guess this should also work because that's already a void statement. Nice. So we should have the correct data in there now. The question now becomes, when we compile the program, do we get sequence points in the right spots? And now the question becomes, if I open up this guy in code, which now only has our sample app, I should be able to say, I guess let's do debugging. This will be .NET Core. I guess what does our debugging configuration look like here? Something like this. Let's see. Oh, where's my other instance of code? Oh, it's here. Let's copy paste this guy over. So workspace folder would be, I guess, our hello app right now. So that would mean we only have to do bin debug hello.dll. I guess that would be bin debug. So, question is, start debugging. What happens if I do F8? Because that's kind of what I want to do. There's no F8. That is unfortunate. I guess you also need a task build. That's fair. So let's do that. Which I guess I can probably just do this, right? So one challenge is, I'm not entirely sure I guess it will help to have the right number of slashes and stuff. I've never tried this with VS Code, so that will be an interesting experiment, but if push comes to shove, we can probably do this with full VS. So So it doesn't seem like this is doing anything. Which is either a problem with VS Code, or that's a problem with our sequence points. So let me just cheat for a moment and open a full-blown Visual Studio here. So let's close the solution. Little known fact, you can actually open exe files directly. I guess step into should work, right? Post PDB not found. That's fine. So let's actually open the source file here. So I also should say I've never done this with .NET Core either. I've done this with .NET Framework, and there it worked fairly easily. So let's see what ends up happening here. Okay, so this has done nothing for us so far, which is funny. So question is, it says, okay, this one I guess makes sense because we're now debugging effectively the native exe, which is not what we want. We want to attach the managed one, which might be a problem the way the debugger is being attached right now. Use legacy managed engine. Now I think this should probably... So let's first try something else, which is let's try our... let's try the managed thing that we know works to make sure that we use the debugger correctly. So let's go to Minsk, src, MSI, let's say, bin debug, open this guy. Yeah, but not like that. You need to open it as a project. MSI bin debug MSI. No. All right, so got well. So we get the same here. That's fine. But let's now open program.cs. Set a breakpoint here in F5. Let's restart. Okay, it's the same problem. So we have the same behavior here. So clearly I am not debugging that the right way. Another thing we can do potentially is what would happen if we put a call here, system diagnostics debugger break, and then we say So we now triggered a basically managed a breakpoint, but for some reason it doesn't look like we have the manage debugger attached. If you open up debug Windows modules vs, will tell you more information. Yeah, I don't think the problem is symbols, because clearly in this case we have symbols because this is the normal C# output. I suspect the problem is more that we are debugging with the wrong engine. I think this is debugging with the native engine. And what we want to do is we want to debug it with the managed engine. But we can totally try this. Debug Windows. Yeah, so it's looking for app host. Okay, that's the native one. Yeah, see this here? Native debugger skipped loading symbols for managed module. What if I say load? Yeah. So the question is, will I have to change the way? What happens if I set legacy to true? What would happen then? Doesn't seem like it changed anything. It has the same effect. Still native debugger. Debugger type auto. Here we go. Let's try this one. Aha! And now suddenly we are sitting on a breakpoint. Okay, cool. So let's try this again. Let's go to samples. Hello. Bin debug. Do not save. Properties. Core CLR. Okay, that's fine. So, modules. Skipped loading symbols. Load symbols. Symbols loaded. See, now our breakpoints here have... See how there's highlighting? And see how there's no highlighting here and no ability to set a breakpoint here? That's because this is an expression statement for which we emitted a sequence point. This is a variable declaration for which we did not emit a sequence point, so we can hit there as much as we want. And if I now restart this guy, then still didn't load the symbols for some reason. But it should also now mean if I actually enter my name, breakpoint is hit. Congratulations. Immo soon to become a Roslyn developer. God, no. I like my friends in Roslyn. They are way more qualified to write this code than I am. So no. Also, it's way more fun to yell at them than to actually fix stuff. All right. So we have some amount of stuff happening here. So locals, you can see there's nothing, even though there is a local. And I can't hover over them because, well, we haven't done anything for that yet. So I think for locals, we have to do some more work. But I would like to put your attention to, okay, this is way too small probably. Can I actually, where's my tool here? D drive, tools, zoom it, zoom it. I mean, God knows what happens when I use zoom it while OBS is running, but that seems to have worked. Look at this stuff here. Oh God, look at this stuff here. We have an actual stack trace and we have correct line information, and it actually kind of makes sense. I mean, it's a bit sad that it says program.main and just not just main, but that's kind of the way we emit this whole thing, but at least that kind of makes sense, right? So now let's actually play with this a little bit. Let's actually go back to this guy here and then see what we can do to make this stuff work here. Because maybe debugging this in VS Code might be easier. So what happens now if I F5 this guy? Okay, nothing happens. How about stop at entry true? Skipping loading symbols. Module is optimized and the debugger option just my code is enabled. That is right. That is exactly why stuff doesn't work the way we want it to. And that's also why debugging symbols are skipped by this debugger. So there's another thing we have to do. And if you, actually we can see this. If we open up our friend ILSpy, I guess in our case, it's probably easier if I do this here. So if we go to can I do CS? Oh, will bad things happen if I do that? Could not find type definition program and type system. Okay, that's fine. Really? Clearly we have a type called program in this one. But in any case, I guess, yeah, it tries to open the exe file. Anyway, so here is the thing. So if you look at this guy here, and we look at this in C#, so it's not quite as painful. Well, that's kind of frustrating, because that was exactly the thing I wanted to look at. Debuggable. Could not decode attribute arguments. Okay. Care to explain why that is? You could resolve all the dependencies. Why are you trouble now doing this? But basically that's what it is. Like this attribute here tells the system that your stuff is debuggable and symbols should be loaded. And it's funny that ILSpy doesn't support that. So let's go to MSDN really quick here. So we have this debuggable attribute. And remember correctly, there's a constructor that takes two bools. Yep, that's the one we want. Is JIT tracking enabled? Is JIT optimizer disabled? So this is the key thing. You want to have fun debugging. You want to set these both of them to true. Not entirely sure what the JIT tracking is doing here. True to enable debugging. Yeah, I guess that's what it is. And so we only have to emit this assembly level attribute. Not a biggie. It just means we have to import this type, which is in system.diagnostics. I'll actually copy and paste the name here, because otherwise bad things will happen, given my typing skills. All right, let's close this guy. And then we just have to emit this call. So let's go to our emitter again. So probably somewhere here would be great. And that would be, well, let's start first in the constructor here. The one code that we didn't like, so that's always a plus. So that would be, we need a type reference, and that is the debuggable attribute ctor reference. Debuggable attributor, no, attribute ctor reference. So, and that's the thing we want to import. Debuggable attribute, this is, yep, that's this guy. Now let me copy paste the, which I already deleted, but multiple things for the win in the clipboard. Alright, so here's our namespace and type name. And then the method name is ctor, and it takes 2 system boolean. And then hopefully this guy can also deal with constructors. Probably not, because we look for ints, we look for statics. We look for, yeah, we look pop. Do we look for statics? If we find the type, great. Methods, where method is method name. Nope, seems like we don't care about static versus non-static. Sweet, so that means we might have the chance of emitting this. How do we emit the attribute? Well, we have to say assembly definition. What is that? Attributes. Main module. Custom attributes. Add new custom attribute. So let's add a custom attribute. New custom attribute. We need a reference for the constructor. So let's do this. This would be our debuggable attribute. Debuggable attribute, which we then add. And I think we have to add something to the call here. Constructor arguments. Here you go. Add new custom attribute argument. And there is a type reference, which in our case would be what is it? Known types. Type symbol bool. And then value would be true in our case, right? We have to pass in true twice. Okay, that may have worked. Pop D, because we were smart earlier. .NET build. And then hopefully I can switch back to my VS Code here. And if I hit F5 now, maybe we have more luck. This is not exactly inspiring confidence. It's an assembly level attribute, not a module level attribute. I think you are right on that one. Which is probably, I probably put it on the wrong thing, right? So I added it to the, oopsie, probably have to put it here, right? Should probably be able to just F5 because we're calling build first. Could not load source hello ms, incorrect format of source message. Interesting. That's a new one. So I guess it didn't like the path that I put in the PDB. So it says at least symbols loaded. That's cool. I suspect it didn't like the fact that it's a path. It probably has to be URL escaped or something. So let me go back again. Let's use full VS again. Or do we don't have full VS? We do have full VS. And let's try this again. See, F5 now works. So I can probably even do this. I should probably be able to just do an F11. Yep, here we go. So now we have an F11. I can do an F10. Booyah. We skip over this one because I don't have a sequence point for this. And now I'm standing on this line. And if I now have F10, it all puts it and the program terminates. So this is cool. So the only thing is now, how do I get this to work in VS Code? And the answer is probably going to be, we have to write this as a URI, if I had to guess. Which, I have too many windows here, but what is that? Emit sequence point. So let's change the format here. And URI is new URI for this. And hopefully when I do this, I get something sane out of this. So it now builds the compiler as well. So that's why it takes so long. And apparently I can't build the compiler. Invalid URI. The format of the URI could not be determined. Okay. URI kind. No. From hex, no. Local. I suspect we have some behavior difference from .NET Core. URI constructor. C# local path to URI. Yeah, what blows up here actually? Is it the toString or is it the constructor? It's the constructor that blows up. See, I'm doing the same thing everybody else does. I just use Google, or in my case Bing, but it doesn't really matter. Well, maybe our path actually is malformed. Is that possible? Is the file name actually maybe blank? No, it can't be completely blank because clearly we were able to find it. Yeah, I guess I suspect it's relative. I think that's probably the problem. So how about let me just hack this one here, and then how meta. We invoke the debugger here, which will now invoke our build of the compiler, which when the compiler finally runs, it will set a breakpoint. And it didn't even work, so that's unfortunate. Why did you not work? Huh. So now how do I debug this easily? I guess this launch, right? And this should have worked, I suppose. Ah, here we go. Okay, so new instance of Visual Studio, please. Debugging your debugger is fun. All right. So now we have our file name here, and it is relative. It is indeed relative, so maybe that's the problem. How about, yeah, it's all fine. How about we do this var full path get full path for the file name, and then how about I just do this? Does it have the debugger to break? No. Ladies and gentlemen, I'm pretty sure we just hit a breakpoint. Oh yeah. And so I can probably also remove these guys now, because we said break on start. So if we do F5, the same effect should happen. Ladies and gentlemen, we hit a breakpoint. Isn't it amazing? I cannot describe. When I first did this, this is one of the most magical feelings ever. If you can actually step through your program, it is so weird. So we just did a single step, emo, booyah, and now we stand here. Like, this is amazing. This is cool stuff. Being able to debug your own programs. So from now on, it's basically just rinse and repeat. So one thing we should probably be doing here, just set ourselves some reminders here. There's some things that are not entirely clean. One thing that is not entirely clean is we should not be computing, I guess to do. We should not be computing paths in here. To do, we should support not emitting symbols. We should not emit this attribute unless we produce a debug build. But those are the kind of two things that come to mind here. And now what we should be able to do, in principle, is go to our loader and say, let's override variable declaration statements and say rewrite variable bound variable declaration. And maybe we're lucky. Let me close this guy here. Let me move this to my second screen so it's not quite as jarring. We don't need this guy anymore. What else do we have open here? They're all on the other screen, it's fine. Alright, so then this is our code base for the compiler and this is our sample thing here. So alright, now if I do F5 here, we should now have sequence points for the variable declaration as well. So let's do I'm somewhat confused now. Yes. Interesting. That flow was a bit odd. So let's try this again. So what's weird is I'm sitting on this statement, but then it's not executed yet. Right, we are about to execute the statement. Right, that's why we don't have anything here. I do a step. Oh yeah, that's right. So now we only have outputted the thing, but we haven't called input yet. Right, now we do another step. Well, now we actually do the input thing. Now I enter my thing. I hit enter and now we're on this line. Alright, so this is basically the flow you would expect to have. And then, again, nothing is output yet. I hit another F10. And then the program ends. Right? So this works the way we want it to. So that's quite nice. So there's a few other things you probably want to handle at this point, which is you want to handle, we basically want to handle the case where we invoke methods, because right now we don't really have any other methods in here. But my challenge is that I have another meeting close in 30 minutes for API reviews. But I think at this point we are kind of like halfway there. So we already have a decent amount of infrastructure ready. So I'm actually kind of ready to call it a day and then just say that's the first step we have for debugging support. And next time we will support F11 and then clean up the remainder here. And then debugging is pretty much almost done. As I told you, it's not that hard. It looks very magical and it feels very magical, but there's a few things we need to do still. But the heavy lifting has been done so far. Do we also add additional sequence point for next statement? I'm not sure what you mean by that. And then are we doing locals as well? Yes, we do locals as well. And the way locals work is also not that hard. If we go to the debugger, let me actually check. I might be able to do this right now. Because it's basically here in the function body. It's something like this for each var. What are our locals called? Locals, okay. For each local in locals. It is something like method debugging information. What is that? Variables. Oh yeah, it's scopes, I think. Yeah, it's something like this. Add new this guy, and then we have to say the variable would be local dot value, and then local dot key dot name. Right. Let's make this a bit easier. Our symbol is local dot key var what is this thing called? Definition. Definition is local dot value. So that would be definition and then symbol dot name. Something like that. So there's something with scopes that I'm not entirely sure I remember correctly. We may have to set this. So if I run this now, it might actually blow up. Let's check. Yeah, this is null. That's what I thought. So this is, what is it, line 273? I'm pretty sure this is this line here. Yeah. So this guy is null, so we have to set this. And I think it's something like you have to, what is it, the range? Yeah, so we can just cheat and we can just say body instructions first, method body instructions last. To only emit this when emitting symbols. Alright, so this is one of those things. So scopes would be a bit more involved if we were to track effectively, you know, different block scopes, if you will, right? Which in our case we don't do because we flatten the whole thing. Should be able to just do that. And then let's see whether we actually get symbol information now for our locals. Ay. Apparently I'm updating the world. So see here, we have no locals. It says name string null. So let's step a few times. And see, now we have locals. It says name is Immo. Isn't that cool stuff? Friends, I still can't get over this. Even though it's not a lot of code and even though it's not a lot of, like, it's still relatively easy to understand what's going on. But even if you do, there's still some weird magic going on when you step through a program that you wrote by yourself in your own language. It's just, it's indescribable to me. That is the fun of building compilers. All right, so then that was fun. So I think we have a decent amount of stuff done for today, and I will commit the stuff. And then next time what we will tackle is we will handle F11 and F10 for real, in the sense that we want to basically handle the transitions if you step into functions and step out of functions. And the other thing we wanna handle is the rewriting of the return statements, right? What I said earlier about setting breakpoints on the opening and closing brace, we want that to work. And then I think we probably also have still time to do some of the cleanups, right? So like ideally when we emit, our emit function on the compilation should probably take, yeah, I guess whether some argument that says you want to debug or not. And probably in our case, the easiest thing is to take a path to the debugging symbols and then change our emitter to only emit debug information if we want to debug, right? We don't want to do this when we build release binaries, right? That would be a good thing to do. I guess that's all I had. Like, if you have any more questions in chat, I'm happy to answer them. And otherwise, I'm happy to go to my next meeting. We are building on top of the core CLR, so to me, this is transpiling to IL. No, that's very true. I mean, like, emitting code for CLR is not that hard. As you know, it should be very clear from watching this, is that there's not a lot of stuff going on, right? If we were to emit native code, then it kind of depends on how we are doing this. You can use LLVM, for example, in which case it's still harder than emitting code for the CLR, but you're still using some sort of library functionality to emit native code. And then again, LLVM handles a bunch of stuff. I'm not sure they support PDBs. I think up until somewhat recently they didn't support it. So that might be an interesting thing to look into as well, because I'm actually still entertaining the idea of eventually just emitting native code, because our language is not... There's some stuff with strings that is kind of implies there's a GC going on, but we can probably change our language semantics to be amenable to write native code as well. But yeah, at the end of the day, like, it's just a different machine you're emitting code for, right? How hard would it be to write emitting PDBs from scratch? That's a good question. I've never done this. I would think that, so PDBs, I've done a PDB reader from scratch a while ago, and PDBs are not documented really well. So if you look at the the C++ PDB file format, that's a bit of a disaster because it's not documented very well. But the portable PDBs are basically the same format as normal ECMA 335 metadata, for which I have written a reader from scratch entirely at some point, but just reading the ECMA specification, and that wasn't too bad. Doing a writer is a little bit more work because you have to keep track of stuff, but at the end of the day, you're writing a binary file that is table oriented, right? So that's not, it's not super difficult. It's just busy work, right? It's just, how you ever write a file format, right? You have to keep track of things. You have to make sure you don't go out of the bounds of individual parts, but it's a fairly straightforward file format. By the time we finish the AOT, we will be there. Well, I mean, even with AOT, right? Like, it's not the same thing as emitting native code. And the reason is not so much that it's not really about these machine instructions, right? Native code is really more about the notion that you don't have a runtime. I mean, they call it the C runtime, but the C runtime is really just a library with a bunch of functions you can call, right? Like printf, right? But the CLR is obviously a lot more, right? There's literally things going on in your process on your behalf, right? So there's a GC running, there's threads that are being started, right? There's exception handling that occurs, right, when you execute code, right? So there's, in that sense, the CLR or any other managed environment like Java, they're a lot more intrusive in the sense that you emit some IL, but there's this other thing on the side that interacts with that starts and stops threads on its own. Versus if you do native code, well, then you emit the native code, that's fine. But then that's also the only code that runs in your process, right? Like, there's no other magic stuff. I mean, of course, if you link to libraries and you invoke functions in that libraries, then that code runs, right? But they usually don't just start threads or, GC the world, right? So in that sense, that's really the difference to me. Even if we have IoT in .NET and I just plug in an IoT compiler, sure, then I emit native code, quote unquote, right? But it will not be the same as, let's say, changing our language backend and emit native code using LLVM, right? Because at that point, we would not have the runtime. We would not have a GC. We would literally have to figure out what are we doing with strings, for example, when we concatenate them. Who's on the hook for freeing them? Do we introduce, you know, a free function somewhere that you have to post to call, right? That's the kind of thing that makes that tricky. What about WebAssembly? Yeah, I mean, with Blazor, we wouldn't have to do much, right? We could just, I mean, at the end of the day, as far as Blazor is concerned, they don't care what language you used, right? Like it's a runtime that runs in the browser that interprets IL, and whoever produced the IL doesn't matter, right? So in that sense, it probably wouldn't be hard to support Minsk in Blazor. The tricky thing there usually is not so much the actual runtime environment, it's the whole design time experience, right? Can you create a project in Visual Studio? Can you reference a Minsk-based project? Can you, when you F5, do we deploy the right things? Do we invoke the web browser? Do we copy the bits in the wrong, in the right spots that everything lights up? But the fundamental act of downloading the P file from the server and running it on the client should already work by the sheer fact that it's IL, right? There's probably some sort of like assumptions around what things are in that DLL that the Blazor things might hook, but there's really not much more from that point of view. Is there a way to have a minimal core CLR runtime? Define minimal. I mean, as I said, like managed code is somewhat intrusive, right? Like you don't really have a way to say, you know, I want CLR but without exception handling, or I want CLR but without GC, right? These things are all intertwined, and so in that sense, it's not really minimal, right? But we do have this thing called CoreRT, which is still on GitHub, which is, depending on your definition of minimal, it's a reimagination of the core CLR runtime, where parts of it are also written in C#. The JIT, for example, as far as I can tell. And the way they solve it is by just AOTing the JIT and linking the resulting native code with the runtime. But it's not really minimal in the sense that you know, you can't just make every feature pluggable, right? The goal of that runtime is to make things more pluggable, so you can have more of a pay-for-play friendly environment where you can say, well, in my case, I don't want to pay for exceptions, so I should be able to run without exceptions. But there is a real ecosystem problem with these things, right? Even if I can build a runtime where exception handling in GC would be, you know, pluggable and disableable, is the resulting thing .NET, right? Because if I say this is the .NET runtime, there's an expectation that I can throw an arbitrary DLL at it and run it, right? But if I have an arbitrary DLL, then, well, what if that code requires exception handling to work and my runtime doesn't support exceptions? Now what, right? So in that sense, it's not entirely clear what you want to get out of this, right? If you want to just get something that is smaller, more lightweight than core CLR, yeah, you can probably achieve that by just re-architecting parts of it, right? But if you want to run any ECMA 335 code, then the things you have to support, that's a long list. That's not really minimal, right? ECMA 335 is like, I don't know how many pages, but slightly more than the YAML spec, and the YAML spec is already 80 pages. I saw a single file design doc in the runtime form factors. Yeah, so I mean, there's a goal to make .NET all up more lightweight, right? So the idea is that, you know, we are not entirely lightweight in the sense that, you know, you look at Hello World and it's like, even with single file, it's, I think, still 40 megabytes or something, right? And that's not to say that we couldn't make it smaller, right? It's more about how do we make the tooling smart enough so that we can safely make things smaller without resulting in this experience where, depending on what your code does, it might blow up because we linked away stuff that your code actually ended up needing, right? And doing that statically is actually very difficult because, you know, most managed environments have a lot of dynamism built into them because reflection is very convenient. So it's not entirely easy for a runtime to know statically what features you need. And that is what makes these things harder. There were some issues with native libs merging with app hosts. Yes, so the single file thing is hard because, you know, single file for managed code, not entirely difficult. You just have to effectively IL merge all these DLLs into one. There's still some issues with that as well, which has to do with reflection, because if you reflect over your application, you may depend on the fact that there are multiple assemblies, right? So for example, if you do things like, DI containers, you might group your types in assemblies and then construct your scopes or your DI containers based on the notion of which assemblies are there. So if we munch everything into one giant assembly, then that code might break. But we can play tricks where we can say, well, even though it's a single file, we have enough metadata in that file that we know which type is from which assembly. So if you ask for the number of assemblies, we can still give you an assembly object that represents that collection of types without actually having different files on disk. That's workable, but then with native code it gets more tricky, right? Because native code, you can't just link a resulting like a standalone DLL, right? That's not how linking works. You can link object files, but you can't link finished executables, right? And so if you want to munch them together, that's much harder. And you can play tricks like embed them as resources and extract them on first launch and stuff, but yeah, it's not really a single file, right? You just have a single file deployment story at that point, but you don't have a single file runtime story. The next meeting you go to API reviews, yes, they will be streamed and in the usual spot. No, today is not a private one. Today is backlog review. There are multi-module interpretations in ECMA standard. Can that be helpful? Well, multi-module in .NET land is... So it's a rarely known feature for most people, but when you build a project in Visual Studio, you basically have 3 different output kinds, right? Ignoring like GUI versus non-GUI, right? You can either produce an exe or you can produce a DLL. The third option you have is called net module. And effectively what this is you have a single assembly. Normally a single assembly is a single module assembly, meaning the assembly only is comprised of one module. But the spec says you can have multiple files that make up the same assembly. The idea there was, well, what if I want a single assembly for some technology, but then parts of my technology is written in F#, parts of it in C#, and parts of it in C++ CLI. Well, then all 3 languages can produce a net module, and then you can basically pretend after the fact that there's a single assembly. I personally think this was complete over-engineering because there really isn't any reason why you couldn't just say, yep, there's now 3 assemblies. Deal with it, right? Like, why would you... Like, the complication to say there's an assembly manifest and it's in one of those 3, but logically you treat it as an assembly, I think that doesn't buy you much. You still have 3 files on disk, right? It's just that one of those files is now an assembly, and logically it's one assembly spanning 3 files. But the inverse is more interesting, in my opinion, which is, you have 3 assemblies, how can I make this one file? Because that's what people really care about. Does that mean there will be more modules in an assembly? Today in C# there's only one module, one assembly. Well, that's what I just tried to explain. Like yes, that's true, but you could imagine a world where it's not the case, right? In fact, if you go to the .NET framework, there's at least one multi-module assembly, and that is WCF. Sorry, it's Enterprise Services. Is it possible to run Minsk and C# side by side? Yeah, absolutely. I mean, in fact, you can already do this. You can reference exe files, right? If you go to, if you create a C# program, you can totally reference the hello exe, not the hello exe because that's a native host in our case, but the hello.dll you can reference from C# and you will see there's an internal type program and it has methods on them. So you can't actually use any of our functions, but if we were to change our emitter to emit a public program type and a public methods effectively, you could call them from C# just fine. C# base assembly plus Minsk code. Yes, so what you can't do today is that's the inverse, right? You can't reference C# code from Minsk because we don't really have a generic importer, right? We only import functions that we know of, like our print function, for example. But in principle, you could imagine a case where we have language syntax that would allow you to say, the equivalent of a using statement in C#, but so that you can actually, call functions that are defined in C# for Minsk. But we don't have that. All right, so now I'm 3 minutes away from our next meeting, so I now have to run. It was fun talking to you guys, and I hope I see you guys on Wednesday when we finish our journey with debugging. Until then, have a great weekend and enjoy your time. Bye-bye.